First set of questions here, we're going to be graphing the following functions. For -4 less than or equal to x less than or equal to 2. All that means is x is between -4 and 2. We're going to write out all the x values and get all the y values, plot the graphs. So whenever you're making a sketch, you're going to want to draw this table. First column is all your x values. Middle column is going to be the function itself with the x values filled in. So you see for like -4, we have 2 times -4, -1 is going to give us -9, all the way down the list. And we're going to get these coordinates here. Once we have those coordinates with these y values, we're going to draw our graph. This is going to be a rough sketch now. I don't have enough room to make it exact, but you're going to have like -4, -3, -2, -1, 1, and 2. And then the y values go from like 3, we'll put 3 like here, to -9. -9 will be way down here. What you're going to want to do is just draw these points. So like, we have -4, -9. That's going to be down here somewhere. Then you're going to have -3, -7. That's going to be somewhere like maybe around here. Then you're going to have -2, -5. Again, down to -2, somewhere around here. -1, -3. And then the y-intercept, 0, -1. So that's going to be like here. Then 1, 1 is going to be somewhere like here. And then 2, 3 is going to be there. So not exact, but then all you have to do here is just connect the dots. Remember, this is a linear graph. It's just 2x minus 1, a straight line. So all we're going to do now is just connect these dots roughly. Hopefully you have a ruler. You'll make it look nicer than me. But yeah, that's all you have to do. If you're graphing a function, remember, just draw the table, put down the x values, fill them into the function, get the y values, plot them, connect them. That's all you have to do. Same here again, but this time we have a quadratic. So we know it's going to be a curve. It's either going to be a happy or a sad face. So again, I just filled in the x and y values, so we're going to have our points. I'll draw the graph here. Now, notice that this is a -x squared graph, or equation. So we know the graph is going to look something like a sad face. Now, we just have to fill in the points. Roughly, the roots are going to be where we have y equals to 0. So we're going to have -4 and 1. So like we'll have -4 here somewhere, and we'll have 1 like here. And we know it looks like a sad face, and the maximum of the graph is going to be like, well, it's between 6. So like we'll just put it somewhere like here. This is a very rough sketch. Again, you should fill in these points, like -4, 0, -3, 4. Fill in all these points and connect them with a curve. Just for the sake of time, this is like a rough sketch of what it should look like. But yeah, always put down the points and always draw the table and then connect them with a line. Next question here, we're going to be dealing with the function f of x is x minus 4. And they want us to sketch the function first between -2 and 6. So, same thing as before. Draw the table. This is an incomplete table, and for the sake of time, I just drew it out before. -2 to 4, but then it should include 5 and 6 as well. But it's a straight line graph. F of x is x minus 4. We know it's going to be a y-intercept of 4 minus 4 down here. Remember, 0 minus 4. And just going to be a straight line. And it'll meet the x-axis at x equal to 4. It's like that over here. So all you have to do here, just remember, connect or draw your dots. -2, -6 is going to be down here. -1, -5 is going to be here. Then we're going to have 0 minus 4, and then we're going to have 1 minus 3, 2 minus 2, 2 minus 2, boom. Just straight line graphs like this. And just connect them on up. And then we're going to have 5, 1, and then, 6, 2 here, when x is equal to 6. I should add that in. Here, boom. So that's the graph drawn. Now, the question asks, what's the domain and what's the range? So, immediately, whenever you see domain and range, just think x and y. Domain is always going to be the x values. The range is always going to be the y values. So our domain, I'm not going to rewrite it. Our domain is just -2 to 4. So it's going to be -2, -1, 0, 1, 2, 3, 4. Sorry, 5 and 6 as well. This is our domain. It tells us in the question. It's just -2 to 6. What is our range? Are the y values we get back from when we fill into the function. So our range here is going to be -6 to 0. So -6, -5, -4, -3, -2, -1, 0, and then 1 and 2 as well. Remember, I didn't fill in 5 and 6 into this table. But that's all domain and range is. Key there is domain is just the x values. And the range is just the y values you get when you fill the x values into the function. Then, the next question asks for get the value of f of 1 and f of x equal to 1 and show these points on the graph. So real quick, f of 1, that is, we're filling in an x value into the function, so we're going to get a y value back. F of 1 will just be 1 minus 4, which is going to be minus 3. Whereas the next one, it's f of x is equal to 1. If we have f of x equal to something, that means we have the y value and we need to get the x value. So we're going to have x minus 4 is equal to 1. If we add 4 to both sides, we'll just get x is equal to 5. So in the first case here, f of 1 equals to minus 3. That means when we fill 1 into our function, we're going to get minus 3 back. And the second one, we have f of x equal to 1. So we have the y value, we need the x value, and we already found that was 5. So these are going to be the 2 points we have. Remember, the difference between these. One of them, we have the x value. The other one, we get the x value. So I'll plot the point 1, minus 3 under this graph here. Go to 1, minus 3, that'll be this dot here. I'll color it in green. And then the next part was saying f of x equal to 1. I'll do that one in blue. So it's 5, 1. So it's going to be this point here. Key there is to notice the difference between getting f of something and getting f of x equals to something. It's either you're getting the y value for the x value, or you're getting the x value for the y value, like in the second case. So now, this question, we're working with the function f of x equals x squared minus 4x minus 5. And the first question, again, is asking us to sketch the function. Now, again, every time they ask you to sketch a function, you should be drawing the table and getting the points, getting the x values, getting the y values, filling in the dots and connecting them. For the sake of time, a little shortcut I like to use. If you factorize this, you know this is an x squared graph, so it's going to look like a happy face because this is a positive at the front. And if we get the roots of these, so like there's going to be a point here and a point here probably. If we get the roots, then we can just draw a rough graph of it. So we know if we factorize this, we're going to have x minus 5 times x plus 1, I think. So we know the roots are going to be at x equals to 5, so that'll be here, and x equals minus 1 here. So the graph is going to look something like this. Again, you should draw it, fill in the dots, and connect them. But for the sake of time, this is going to be what the graph roughly looks like. And now, the main point here is using the vertical line test. We want to see if this is a function. The vertical line test, literally, all you have to do is just see if you can draw a line vertically down through your graph, and it has to only intersect the graph once. There could only be one y value for each x value. We can't have 2 y values for a given x value. So for this function here, like, you can draw a vertical line through any point in this, and we can see it only intersects it once. So that means, using the vertical line test, we've proven that this is a function. Then, we have to rewrite it in the form f of x is a x minus h squared plus k, using the quadratic transformation method. This is very tricky. Well, we'll take it step by step. So we have x squared, x squared minus 4x minus 5. First step here is something called complete the square. Well, normally to get this a here, you would factor out something from the x squared and the x. Well, technically here we have a 1. We can factor out x squared minus 4x, and then minus 5. Now, we want to write a square in this bracket here. Well, if we write x minus 2, x minus 2 squared. When we square this bracket out, remember, using split and repeat, we're going to have x squared minus 4x plus 4. That's what we're going to get when we square that bracket out. So what we're going to have to do is, because there's a plus 4 here, remember, in this bracket, we don't have a plus 4. We're going to have to write a minus 4 here. And we do that because then when we square this bracket out, this plus 4 will cancel with this minus 4 here. And we're going to just be left with x squared minus 4x. So remember, first step, factor out something. In here, in this case, it was just a 1 we could factor out. Then we have to complete the square. Just rewrite this as a square. And then, account for whatever additional term you have. So now, if we multiply out that minus 4, we're going to have x minus 2 squared. 1 times minus 4 is just going to be minus 4, then minus 5, like we originally had. So our final answer will be x minus 2 squared minus 9. I'll draw a box around it. Oop. Like that. So these are really tricky. They take a lot of practice. The hardest part is the square part here. But just looking at this, you know that 2 squared is equal to 4. So, it takes a bit of guesswork, and always multiply out this bracket. So you can see what you get, and you can see what number you have to like either take away, you might have to add a number to make sure this whole bracket here should be the same as this bracket here when you multiply everything out and minus whatever. Okay, now we're moving on to trigonometric functions, and we want to sketch this function. F of x is 2 sine 4x minus 1 for minus 2 pi less than or equal to x less than or equal to 2. Now, again, sketch a function, draw the table, draw the x values, draw the y values, fill into the function, and then connect the dots. For this one, I'm going to show a different way of thinking about it. So, typically, if we had a graph of sine x, we know it's 2 pi periodic. That's a key with sine x, 2 pi periodic. So it's going to look something like this. It'll repeat itself every 2 pi. And like same down here, it'll go like this, and then that down here will be minus 2 pi. Normally, that's what a graph of sine would look like. But we have 2 sine of 4x minus 1. The key here is, first of all, we're multiplying it by a 2. So we know it's going to be twice as high as it normally is. And we're multiplying the x by a 4. So we know it's actually going to fluctuate a bit more. The period is going to increase. Remember, I'll draw it over here in green. The period, or this is kind of like a sine nx. That's the general form we normally work with. So n in this case is going to be 4. So the period is going to be 2 pi divided by n. So n in this case is just 4. So we know the period is going to be pi over 2. So instead of the period being 2 pi, it's going to be pi over 2. So we know it's going to fluctuate a lot more. It's going to be twice as high, the amplitude, but it's also minus 1. So it's going to be a little shorter than it normally is. If there was no minus 1, we would have the amplitude going from 2 to minus 2. But we have a minus 1 here. So it's going to go from 1 to minus 3. And remember, it fluctuates with a period of pi over 2. So it's going to look something like this. It's going to be a rough sketch. And then it's going to come down like this. Just do that. Remember, the peaks are at 1, and then the peaks down here at minus 3. These are not to scale, but you know what I mean. So it repeats itself every pi over 2. So like here, we will have pi over 2. Then here, we would just have pi. And then here, we would have 3 pi over 2 minus pi over 2. I won't bother drawing it. You get the gist. When you're sketching the graph, you're going to have to change. Like this should go all the way out over here to 2 pi somewhere. And then all the way down here to minus 2 pi. These are very large x intervals for the question. But what we're trying to test here is that you understand that, okay, the 2 at the front, that means it's going to be twice as high. The 4 in front of the x, that means, okay, it's going to oscillate 4 times as quickly. And then the minus 1 at the end is like, okay, it's going to shift the graph down by 1. And then when you sketch it, it should look something like this. Then, down here, what is the amplitude, range, and period of this function? Range and period you've probably seen before. Amplitude is just like the maximum kind of distance the graph goes away from like the neutral position. Basically just the number in front of the sine. So here we have 2 sine of 4x. So the amplitude is going to be 2. Because that's how, that's like the size of the waves above and below, like the neutral point. See, like the neutral point here isn't at the origin, or isn't at the x equals 0. Y equals 0, I should say. It's between 1 and minus 3. So it's going to be at minus 1. And relative to minus 1, the graph will go 2 above and below. That's how you know what the amplitude is. The range then is just like the biggest and smallest value on the y-axis. So we know it's just going to be 1 and minus 3. So the range is going to be minus 3 and 1, like this. And then finally, the period. We already got the period. It's, 2 pi divided by n. That's equal to 2 pi divided by 4, and that's going to be pi over 2. This formula here is not given in your log tables, so it's very important you actually learn that equation. Because, sometimes you might say n over 2 pi, like I did earlier. Always, period is 2 pi divided by n, and n is the number in front of the 4x. So, try your best to learn that equation. It's very important. Everything trigonometric, when you're working with sine, cos, and tan, you might have to get the period. The easiest way to get the period. Last question here, we're dealing with composite functions and inverses. So we're given 2 functions. F of x is x squared minus 1, and g of x equals 3x plus 1. We want to find f of g of x and g of f of x. Remember, f of g of x means we're going to fill g of x into f of x. So f of g of x is going to be 3x plus 1 squared. Remember, we just fill this into the x value here, and then we have minus 1. And now you should use split and repeat to multiply this out. I'm going to do it quickly. It's going to be 9x squared plus 6x plus 1 minus 1. That's going to be 9x squared plus 6x. So that's f of g of x. And then you have g of f of x. This time, we're going to be putting this into the x in g. So that's going to be 3 times x squared minus 1 plus 1. So that's going to be 3x squared minus 3 plus 1. That's going to be 3x squared minus 2. Just remember, if it's f of g of x, you're just filling in what's in the bracket into the other function. Last part of this question, we want to find the inverse of g of x. So g of x is equal to 3x plus 1. Yeah, 3x plus 1. Now, whenever we're finding the inverse, we're always doing the same steps. First step, number 1, we need to write g of x as y. So y is equal to 3x plus 1. Second step, we want to rearrange to have x on its own. So we're going to bring the 1 over first. We'll have y minus 1 is equal to 3x. And then when we divide by 3, we're going to have x is equal to y minus 1 over 3. Then, third step, just switch the x and y's. We're going to have an x at the front. We're going to have a y in the front instead. And then the y up here is going to become an x. Like this. That's the third step. And then the fourth step is just rewrite the y as g to the power of minus 1 of x. And that's equal to x minus 1 over 3. So that's the inverse function of g of x. G to the minus 1 of x is x minus 1 over 3. Whenever you're asked for the inverse of a function, it's those same 4 steps. Write the function as y, rearrange to get x on its own, swap the x's and y's, and then just relabel it as g to the power of minus 1 of x or f to the power of minus 1 of x. And that's how you do an inverse of a function every time.